reliability test in SPSS based on Cronbach's alpha equation for a Likert scale data extracted from questionnaire or a survey. These Likert scale are based on 2 point up to 11 point Likert scale. Cronbach's alpha or alpha coefficient was developed by Cronbach in 1951. The alpha or the test describe the consistency of items. It does examine whether questionnaire would reproduce the similar participant outcomes if it was repeated under the similar conditions. The alpha refers to how closely related a set of items or questions in a survey. It assesses the reliability of items, and it does measure the internal consistency for items. The alpha also measures the internal relatedness of the items. The alpha coefficient have a reliability range from 0 to 1. If all items are not related, then alpha equals to 0. If all the items co-vary, then alpha is close to 1. Cronbach's alpha increases as the intercorrelations among test items increase. The Cronbach's alpha scores of a 0.9 or equal to 0.9 or greater indicates excellent reliability, and an alpha value of less than 0.5 means low reliability. Cronbach's alpha formula is built on the Couders-Richardson 20 formula. It can be used for the analysis and finding and testing the reliability of a data that is based on a scaled responses, such as Likert scaled items from 2 up to 11 point Likert scale. The formula also can be used for continuous variables such as ratios or intervals. It can also be used for determining the reliability for a data that is or are binary. So it is suitable to be used for binary variables such as multiple choice questions or a dichotomous variable that have two options, yes or no. The formula for the Cronbach's alpha as given here is equal to k divided by k minus 1 multiplied by 1 minus, between bracket 1 minus the sum of the variance on the upper part for the items divided by the variance for the total score in the lower part. So from this formula, the k represent the total number of items and the variance I represent the variance associated with each item, and the variance T is the variance linked to the observed total score. In the next slide, a reliability reference table shows the Cronbach's alpha value ranges from 0 to 1 and the reliability level for that value. Reliability test in SPSS based on Cronbach's alpha equation for a 5-point or 2-point Likert scale questionnaire or survey. Reliability tests in SPSS using Cronbach's alpha equation for a 5-point Likert scale questionnaire or a survey. The test will measure the internal consistency of items and whether the questionnaire is reliable, and if the survey or questionnaire is repeated on different time and date with the same group of participants, their responses will be similar. That's indicate reliability. And the way to evaluate and assess a questionnaire is to perform a reliability test using the formula that has been generated by Cronbach, and it's called Cronbach's alpha equation. That is equal to K divided by K minus 1. K stands for the total number of items or questions, multiplied by a bracket 1 minus the sum of the variance for each individual items, divided by the variance for the total score achieved by the participant. The value that is generated from the Cronbach or Cronbach's alpha ranges from 0 to 1. 0 means that the questionnaire is unreliable, and a value of 1 for alpha means that the survey or questionnaire is 100% reliable. Here in this SPSS, I had inserted data taken from a questionnaire that has been answered by 20 participants who gave their opinions on 20 questions, 20 items, item number 1 to item number 20, and their responses was inserted as a score based on the 5-point Likert scale from 1 to 5. 1 indicates that the participant is strongly disagreeing with the statement or the question. The 5 value reflects a strong agreement with the statement. A value of 3 means that the participant is neutral. To evaluate and assess the quality of the questionnaire or survey, reliability tests based on Cronbach's alpha can be used and performed here in SPSS. The way to do that first is to calculate the total score achieved by the participant, i.e. to count all or add up or combine all the scores achieved or reported by each individual participant for each individual item, i.e. combining the values for all the items for each individual participant. So to do that, to do this first step, first click on transform, then click on compute variable, and in the compute variable we are going to generate a variable or a column of data, and we call it total score. And to do the total score is first to add all the values here, and to do that is to select on the function group, click on all, then scroll down to statistics, and then from statistics use the function or the command for sum, drag that into the numeric expression. So we're going to combine and add the value for each individual participant. So see here the command is sum between brackets, and then we are going to add the first item here separated by the comma, and then add the second item. So we're going to repeat separated by comma, and we're going to insert the third until the item number 20. Every time we insert the item has to be followed by a comma. Insert comma and then item number 7. So we have 2 3 4 5 7, then 8 9 comma 10 for the rest of the items. Item number 14, 15 comma 16 comma 17, and then comma 18, and then item number 19 comma item number 20. So we have placed all the items between the brackets separated by comma. If we click on OK, a new data variable is generated on the far right hand side. This represents the combination of all the scores for each row or for each participant, and I'm going to do a few editing on that column or variable by clicking on variable view, and I'm going to reduce the column width to 6 and make the scores center, and reducing the decimals into 0. Once the total score is calculated for each participant, the next step is to transpose this data, move these items into this side, and then the ID for each participant into the other part here, upper part. And the way to do that is to click on data, transpose, and then in transpose I'm going to select the variables from item number 1, select A, deselect this, and also include the total score variable in it, move it to the variables box, and then in the name variable going to move the ID into that box. And if I click on OK, again a data view is generated. Now the items are in here in this case are inserted in rows, and the student ID is in columns or variables label. And I'm going to do a few editing for this data. Transpose data. The first one is to reduce the column width into 6, and then to align the data into the scores into the center for all the data. And then I'm going to change also the labeling of the variables by clicking on the column here, then control find and then replace, and I'm going to replace the K underscore with an S for student. Replace all. These all has been renamed by labeled as S1 to S20, student number 1 to student number 20. If I close that and go to the data view, again these are labeled here as S1 to S20, and on the column here item number 1 to item number 20, in addition to the total score. So now we had done the second step. The third step is to try to determine the values for each component of this formula. K is the total number of items or questions, which is 20. For the variance for the items or each question, we need to calculate that and then add the variance for all the items together, and then divide that by the total score variance. And if we go back again here to the data view in SPSS, I'm going to calculate the variance for all the items with the total score. And the way to do that is to click on transform, compute variable, and then I'm going to generate a target variable, call it variance, and I'm going to use a function group by clicking on all and then scroll down to statistical and then select the variance command and drag it up to the numeric expression. Again, we're going to do the same thing, calculating the variance for all these variables from S1 to S20, and the way is to insert these between each item between the brackets. Insert the S1 first, separated by comma. Insert the S2 by comma, S3 and S4 and S5 and then S6 and then 7, 8, 9, 10, 11, 12, separated by comma. Every time you enter a variable, you separate that by a comma, and then 16, 17, comma, 18, comma, 19, comma, 20. So we had inserted all these variables between the bracket from S1 to S20. If I hit the OK button, a value is another target variable is generated on the far right hand side that calculate the variance for each individual item, for item number 1 to item number 20, in addition to the variance for the total score. So the variance for the total score is this value, and the variance for each individual item is this value. I'm going just to do a little bit of editing here by making this into the center and then reducing this into 6 and back again to the data view. I'm also going to reduce the decimals for these scores here by clicking on converting this into 0 decimal, but keeping the variance with 2 decimal points. So we have now most of or all the values for the part of the equation. We have the variance for each individual items. We have the variance for the total score. We need to find out the sum of the variance for all the 20 items. To calculate the sum of the variance for the items, we need to add up all these values. First of all, I'm going to Control X, remove this value from here, place it into the equation here in this equation, as this is the total score variance, and I'm going to replace it here by copy and paste, and back again to the data view here, and to calculate the sum of the variance for the items, click on analyze, click on descriptive statistics, click on frequencies, and then click on statistics and select the sum command here, click on continue, and we're going to calculate the sum for the variance column or target variable, and I'm going to untick the display of frequency. If I click on OK, a table here generated showing the sum of the variance for all the items from item number 1 to item number 20, which is equal to 27.1 approximately. So I'm going to, and this represents the upper part of the formula, so it is 27.1. So far we have calculated the variance for the total score and the sum of variance for all the items. The next step is to calculate and determine the Cronbach's alpha following the equation as given here in this formula. For K here, K represents the total number of items, which is 20, divided by 20 minus 1 equal 19. At this stage we need to use a calculator. Here I have a calculator, and I'm going to use the calculator to determine the Cronbach's alpha value. We need to calculate the value between these two brackets. 1 minus 27.1 divided by 119.63 equal to this value, and we're going to multiply that by 20 equal, then divide that by 19, and a value of 0.81 is generated. So the alpha value here is equal to 0.81. What does this value mean? This value means that the questionnaire or the survey is 81% reliable. The table here shows the Cronbach's alpha value and the level of reliability. If the alpha value is equal to 0.9 or greater, then the reliability is excellent for a questionnaire. If a survey has a Cronbach's alpha of a range between 0.8 and 0.89, then the reliability is good. Reliability will be acceptable when the range for alpha is between 0.7 and 0.79 or 0.79. The questionnaire will be considered questionable when the alpha value is in the range of 0.6 to 0.69, and the survey would have a poor reliability when the alpha value is between 0.5 and 0.59, and the questionnaire or a survey will be unacceptable or unreliable when the Cronbach's alpha value is less than 0.5. So this is the way to evaluate and assess the reliability of a questionnaire or a survey based on the Cronbach's alpha equation. Evaluating the reliability of a 2-point Likert scale questionnaire or a survey in SPSS using a Cronbach's alpha equation. The test will measure the internal consistency of items and test whether the questionnaire or a survey, if repeated on different dates or times with the same group of participants, will produce or generate similar outcome or responses from the participant. And the way to evaluate the reliability is to do a reliability test using the alpha equation, which is equal to K divided by K minus 1. K stands for the total number of items or questions, multiplied by 1 minus the sum of the variance for each individual item or question, divided by the variance for the total score. Here in this SPSS data view, I had placed data extracted from the responses of 20 participants in a questionnaire answering 20 questions or items, giving their opinion on a specific question, and their response was scored based on the 2-point Likert scale. 1 stands for agree and 0 stands for disagree. So these data are dichotomous categorical, as there is only 2 options, either agree or disagree. And to evaluate the questionnaire and to determine whether the survey or the questionnaire as a whole is reliable, then we will do the reliability test based on the Cronbach's alpha equation. The first step is to calculate the total score obtained from the participant giving their opinion on each specific questions or item, i.e. combining the scores achieved or recorded by each individual participant. To do that is first to click on transform, then click on compute variable. In the compute variable, I'm going to generate a target variable, call it total score, total score, and to add and combine the values for the scores achieved by each individual participant, we're going to use the sum command. And the way to do that is to click on the function group, scroll down to statistical words here, click on statistical, then select the sum command and drag it into the numeric expression. In the numeric expression, we're going to add the variable for the Q number 1 to Q number 20 in between the bracket, separated by a comma. So we're going to insert the first item or variable or question, followed by comma for the second one, and then for the third. Every time insert a variable, need to separate it by a comma from the next item or variable. Question number 10, and then 11, and then 12, and then 13, and then 14, and then 15, 16 towards the last one, which is Q20. So we have inserted all the items or variables between the bracket, and if you click on OK, a target variable is generated here on the right hand side for the total scores recorded by each participant. Going to do few editing on this target variable, going to reduce the width of the column into 4, and I'm going to make the data centered, and I'm going to keep the decimal to 0. So we have calculated the total score. The next step is to transpose these data, and the way to do that is to click on data, scroll down to transpose, and in the transpose I'm going to move the ID into the name variable, and I'm going to select all the variables and drag them into the variables box and click on OK. The data is transposed in a way that now we have the questions or the items in rows. I'm going to do few editing here, since we're going to be interested in just using 2 decimals, so we make all the rest of the values 0 decimals, and we're going to align the scores into the center. Select and then drag, and I'm going to decrease the column width into 4, keep it at 4 for all the target variables. And we're going to, since we have here a dichotomous, we are going to measure the data based on nominal. Copy and make it nominal, and going to change the label here from K1 into S1, and the way to do that is to select the column here and then Control F for find, and click on the replace, and then type K underscore, and then replace that with capital S4. And if you click on replace all and then close, and we can see here all the label has been changed to S1 to S20, from S1 to S20. So now we have calculated the total score, transpose the data, edit the data. The next step is to calculate the variance for all the items or the questions, and also to include the variance for the total score. And the way to do that is to click on transform, compute variable, and then I'm going to type here a variance for the new target variable to generate, and I'm going to select from the function group under statistical the variance, dragging the variance into the numeric expression. So we're going to calculate the variance for all the items and for the total score. Again, we need to insert these variables in between the brackets followed by the comma for S1, and then insert the second comma, and then comma in between the variables, otherwise the command will not be executed. comma, and then S4, comma, S5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, until all the variables are included in the brackets. Last one here. So now we have inserted all the variables from S1 to S20 in between the bracket, and if we click on OK, a new target variable is generated that is called variance. And as we can see here, we have the variance for each individual item or question and the variance for the total score. I'm going to do a little bit of editing into the variance variable. I'm going to align it into the center, and I'm going to reduce that into 4, and I'm going to keep it as a scale for the variance, and I'm going to do no more changes here. So now we had calculated the variance for each individual items and the variance for the total score. So following this formula, now we had most of the values for components or part of this equation already determined. We need to add up all the variance for all items in SPSS, and the way to do that first is to click on the variance for the total score, and I'm going to remove that and place that in this formula here. So we have now the variance for the total score in the equation. The next step is to add all these variance together from item number 1 to item number 20, and the way to do that is to click on Analyze, scroll down to Descriptive, select Frequencies, select Statistics, click on Sum, click on Continue, then select the variance as we are going to calculate and add all the value within this variance, and then click on OK. A small table here is generated showing the sum for the variance, which is 4.82. So we're going to use this formula and type here 4.82. So we have now the value for the sum of the items variance, or the variance for all the items. So we're nearly now ready to calculate the alpha value. The K value here is the total number of questions, which is, in this case, is 20 divided by K minus 1, which is equal to 19. So we are ready now to work out the value, and I'm going to use a calculator for this purpose. So if I type calculator and then click on calculator here, and I'm going to first of all find the value for the scores here between these two brackets. So I'm going to divide the upper part by the lower part and subtract that from 1. So 1 minus 4.82 divided by 45.73 equal 0.89. I'm going to multiply that by 20 and then divide that by 19. which will give us a value of 0.94. So this value here means that this questionnaire or this survey is 94% reliable. So it has high reliability value. Thus, this questionnaire is excellent in reliability. From this reference table shows the Cronbach's alpha value and the reliability level. If the alpha value is equal to 0.9 or greater, then the reliability is excellent. If a questionnaire have a alpha value of a range between 0.8 and 0.89, then the reliability is good. Questionnaire will have an acceptable reliability when the range for alpha is between 0.7 and 0.79, and a survey will be questionable in reliability if the value is between 0.6 and 0.69 for alpha, and it will be a poor questionnaire if the value of alpha is between 0.5 and 0.59, and a questionnaire will be unreliable, unacceptable if the value for alpha is less than 0.5. So this is the way to calculate and determine the Cronbach's alpha for a questionnaire that have a dichotomous data in it, binary data, 2-point Likert scale, 2 options for the participant to choose from, either agreeing or disagreeing. This is the way to do it in SPSS.